Okay, so today we're talking about pH. pH is a scale. It ranges from 0 to 14 with a neutral point of 7. The pH scale really represents a measurement of hydrogen ion concentration. So with this, let's look at the scale. Let's see what we have. Okay. So this is our basic pH scale. Where down here we know we have 0, up here we know we have 14, and 7 is our neutral point. Really, if you look at it very, very simply, anything below 7 is an acid or more acidic. Anything above 7 is considered a base or just more basic. You could also say that anything above 7, since it is more basic, is less acidic. Just as well you can say everything below 7 is more acidic and less basic. So let's write it out. Okay, does that make sense? Alright, the second point. Now that we know what's an acid and a base, we look at it using the definition. Anything that's acidic will mean that it has a higher hydrogen ion concentration. Anything that's more basic will have a higher hydroxide ion concentration. So if you look at it both ways, anything here below 7 that is more acidic, less basic, will have more hydrogen ions and less hydroxide. Flip side, anything that is more basic, otherwise less acidic, will have less hydroxide ions, more hydroxide ions and less hydrogen ions. So like most other things that we've covered even so far, this is really a big game of opposites. So look at the scale carefully. 0 to 14, 7 is neutral. What is neutral? If you take hydrogen and hydroxide together, what does it give you? It gives you water. Water is our neutral point because it's a mixture of hydrogen and hydroxide equally, which is why water has a neutral pH. Anything that has more hydrogen ions or gives off more hydrogen ions will be known as an acid. Anything that tends to give off more hydroxide ions will be more basic. So as I said in the beginning, a base will be a base, or otherwise known as less acidic, and an acid will be less basic. Okay, let me clear up everything here. This is really what the takeaway is. If you compare acids to bases, what can we say? Acids are on the scale in what way? From 0 to 7. We can also say they are higher in hydrogen ions. We can also say they are known as proton donors. With bases, these are from 7 to 14. And truthfully speaking, acids are 0 to 6.99 and bases are 7.01 to 14. Okay, bases will be lower in hydrogen but higher in hydroxide. That's the difference. So if we go back to our acids, acids are higher in hydrogen, and what are they lower in? hydroxide. Since acids are known as proton donors, bases will be known as proton acceptors. Okay, that is everything you need to know about what an acid is and about what a base is. Let's do some examples. Compound A compared to compound B. Compound A has a pH, let's just say, of 6.53. Compound B has a pH of 5.47, just as random numbers. If I ask you which compound is more acidic, it's compound B. Which means which compound is more basic? Well, that would obviously be compound A. Even though we say compounds below 7 are acids, clearly 6.53 is a higher number than 5.47. So compound A appears to be more basic. And it appears to be less acidic. So this is more acidic. This is less acidic. Okay. Which means this is less basic, and this one would be more basic. It's really just a play on opposites. Or if I asked you, which one of these compounds has the higher hydrogen ion concentration? Again, whichever one is more acidic means it has more hydrogen ions. So this one, again, compound B, would have more hydrogen ions. Which would have less hydrogen ions? That would be compound A, having less hydrogen ions. Okay, hopefully this helped. The only other section of this topic that we covered is buffers. I really don't have anything to draw for buffers. A buffer system is nothing more than the body's attempt to correct an imbalance. So let's just say if our blood pH is 7.35 to 7.45, let's just say we ate the wrong kind of food and we take an antacid. What would an antacid do? An antacid would make our pH higher, right? It's trying to get rid of all the acid. So let's say the antacid, if we took too much of it, brought our pH up to a 7.53, which is out of the normal range of blood, 7.35 to 7.45. If the antacid brought up the pH to 7.53, what does this mean? It means our blood became too basic, right? Well, that's the challenge here. So really what's happening is the body is going to depend on the kidney to correct this imbalance with several other systems. But as a buffer system, we just want to know that we were acidic in the first place, but the antacid brought the pH up. Okay, guys. Thank you very much, and good luck.